Welcome to the Slop Temple. We pray this video helps.
You start by enabling the integrated GPU in BIOS and allocating UMA memory. This is the first actionable move. Once done, set the UMA frame buffer to a reasonable value like 512 MB or 12 GB based on total RAM so the GPU can borrow system memory. Make sure to save and reboot immediately, then check Device Manager to confirm the iGPU appears. This step gives the OS a pool of shared GPU memory to use. Without it, the OS won't expose shared allocation. Once the hardware allocation exists, install the latest AMD chipset drivers and Radeon software because drivers control memory sharing and performance. Then enable hardware-accelerated GPU scheduling in Windows when supported. This reduces latency for shared memory transfers. Make sure to configure the page file. System managed works, or set a custom size of about 1.53 times RAM to avoid out of memory during heavy allocations. Finally, restart. The OS will now be able to use system RAM as shared GPU memory. You finish by testing and tuning. Run a GPU workload and watch RAM and shared memory usage in Task Manager or Radeon metrics. If performance is poor, increase UMA or tweak the page file. If instability appears after driver updates, roll back to the prior driver. Make sure to update BIOS if iGPU options are buggy. Troubleshooting tip: if the system crashes or shows artifacts, reset RAM modules and test one stick at a time. Faulty RAM often mimics shared GPU memory failures.
Thanks for watching. Consider subscribing if we helped you.